In this video, we're going to be discussing absolute value inequalities. Now, before we start talking about absolute value inequalities, it's going to do us some good to review graphing inequalities. So let's talk about this. When we graph an inequality, the first thing we want to know is, are we going to be using an open or a closed circle to plot our point? And to decide this, we want to look at our inequality symbol. If our symbol is a greater than symbol or a less than symbol, then we want to use an open circle. If our inequality circle is greater than or equal to or less than or equal to, so if it has the equal to symbol, then that's representing that that point is part of our solution, and we want to use a closed circle to represent that. All right, so if I say take a look at my two examples down here at the bottom, x is greater than 3 and 2 is greater than or equal to x, I want to go, okay, this is greater than, it does not have an equal to bar, so it's an open circle, and it's at positive 3. The number that's in the inequality is always where our circle goes. So I'm just going to make an open circle at 3. If I look at this one, 2 is greater than or equal to x. Well, that's telling me I've got my equal to. So that's telling me it's a closed circle. So I want to go to 2. And for this one, instead of an open circle, I'm going to put in a closed circle. I'm going to fill that circle in because 2 is part of the solution and 3 is not part of the solution in this one. Okay, so that's step 2. I've plotted the circle. Step 3 is to use a test point to decide which way to shade. Okay, so a test point is just a point that is not the point that's given to you in the inequality. A good one to always use is to use the number 3, or use the, sorry, not 3, to use the number 0 if you can. So I'm going to plug in 0 for x. So 0 is greater than 3, and 2 is greater than or equal to 0. And what I want to do is I want to look at these two inequalities that I just made. I want to say, are those true? Right? Does that make sense? Is 0 bigger than 3? Well, obviously that is not true. 0 is not bigger than 3. So I do not want 0 to be in my solution. I do not want 0 to get shaded. So if 0 is on the left-hand side of the circle and I don't want it to be shaded, then I want to shade in the other direction. I want to shade to the right-hand side. Okay, I want my graph to be shaded this way. And every number that is on this side of the circle is part of the solution. If I picked another one, say I picked 5, I go, okay, 5 is greater than 3. Well, that's true, that works. Okay, so I want 5 to be in my solution, so there we go, it is, so I know I shaded in the right direction. If I try that over here, okay, I plugged in 2. 2 is greater than or equal to 0. Well, is that true? Yeah, 2 is bigger than 0. Okay, it has to be one or the other, bigger or equal. In this case, 2 is bigger than or equal to 0. So I do want 0 to be in my solution. Okay, I could pick another point. 2 is greater than or equal to, let's say, let's plug in 6. Well, is 2 bigger than 6? No. So I don't want 6 to be in my solution, so I don't want to shade with 6. I do want to shade with 0. So I'm just going to go ahead and shade in this one, the left-hand side of the number line. And that's saying that every number that is to the left of 2 is part of the solution. And in this case, 2 is also part of the solution because of the equal to. So that's just a review of how to graph inequalities. Let's now talk about absolute value inequalities. So an absolute value inequality is just an inequality with the absolute value in it. Similar to a absolute value equation, it just has an absolute value. So some examples are like absolute value of x is greater than 3, or absolute value of 2x plus 5 is less than or equal to 3. All these are inequalities with absolute values in them. So let's talk about how to solve one. So the process for solving an absolute value inequality is very similar to the process for solving an absolute value equation. Our first step is to isolate the absolute value, get the absolute value by itself on one side. Second step, to split the inequality into two inequalities, one of them with a positive result and one with a negative result. Now the key thing here that wasn't an issue with equations is that when we split these, on the side with or on the inequality with the negative result, we want to flip our inequality symbol. If it's greater than, it becomes less than. If it's less than, it becomes greater than. Then we want to solve both inequalities, and then we just want to graph both inequalities on the same number line. So let's go ahead and do this. So example 1, we want to solve and graph 3 times the absolute value of 6x plus 1 is greater than 39. So first step is to isolate. So looking at this, the only thing I have that's outside of my absolute value is this 3, and it's being multiplied. So to get rid of it, I want to divide by 3 on both sides. Divided by 3 makes that 3 go away. And on this side, 39 divided by 3 is 13. So now I've got the absolute value of 6x plus 1 is greater than 13. Because the absolute value is by itself, now it's time to split. And we're going to split this absolute value inequality up. Now watch what happens, and this is important to notice on the one where I make it negative. Notice I have one inequality with a negative result, one inequality with the positive result. For the inequality with the positive result, all I did was take my absolute value bars away. There's my new inequality. For the one with the negative result, I also flipped my inequality symbol. And that's really important to remember that you do that. So now I want to solve both inequalities. First step, get rid of this plus 1 by subtracting 1 on both sides. Okay, this one goes away, and I've got 6x is less than negative 14. This one goes away, and I'm left with 6x is greater than 12. Got to get rid of that 6, so I want to divide both sides by 6. The 6 goes away everywhere. All right, on this one, I've got x is less than, well, negative 14 over 6. It doesn't work out to an integer, so I'm just going to leave it as a fraction for now. And over here, this one, 12 divided by 6 is just 2, so that's easy. Okay, I want to deal with this one. Because it's a fraction that is not simplified, I want to simplify it. 14 and 6 are both divisible by 2, so I'm going to divide both 14 and 6 by 2 to simplify my inequality so that I end up, I should have an inequality or a division bar on it. 14 divided by 2 is 7, and 6 divided by 2 is 3, so this is negative 7/3. Okay, so here are my two answers. X is less than negative 7/3, and I've got x is greater than 2. So to graph them, I want to put a circle at negative 7/3. Okay, 7 divided by 3 is 2.3 repeating, so that's like right here. And there's no inequality symbol, or there's no equals to symbol on here, so I want that to be an open circle. 2 is just 2, and once again, no equal symbol, so it's an open circle. And now I want to graph them. All right, I'm going to graph them both these inequalities, put them on the same number line. Once again, I want to use a test point. I'm going to use 0 for x, so I plug in 0 less than negative 7/3. So the question I'm asking myself is 0 smaller than negative 7/3? Well, no, negative 7/3 is a negative number and 0 is bigger than every negative number, so this does not work. And because that does not work, I don't want 0 to be in the solution for this inequality, so I want to shade to the left. So I'm shading just to the left of that circle. And now I want to do the same thing over here. Okay, x is greater than 2, so I'm going to plug in 0 for x greater than 2. So now I ask myself, is 0 bigger than 2? Nope, it's not. So I don't want 0 to be in the solution for this one, so I want to shade the opposite direction. This one I want to shade to the right so that 0 is not included in my solution here either. And there we go. I've graphed both my inequalities on the same number line. So my answers are x is less than negative 7/3, or x is greater than 2, right? And my graph that looks like this. Let's take a look at one more example. This is example number 2. So I've got negative 4 times the absolute value of 2x minus 5 plus 5 is greater than negative 23. So there's a lot to do in this one, lots of work to work out here. So I want to start by isolating my absolute value. So I'm going to do that. I got to get rid of this plus 5 first. So I'm going to subtract 5 on both sides. I end up with negative 4 times the absolute value of 2x minus 5 is greater than negative 28. To get rid of a multiplying by negative 4, I want to divide by negative 4. Just do the opposite. Now something's important here to remember. We're dividing by a negative number. And with an inequality, when you divide by a negative number, the inequality symbol flips. It's something you have to remember from back in 8th grade math and algebra 1, that anytime you divide by a negative number, the inequality symbol flips. So I'm left with absolute value of 2x minus 5 is less than positive 7. All right, so now we can go ahead and separate. So to separate, one of my results becomes positive, and one of my results is negative. And once again, on the result that is negative, I flip that inequality symbol back. All right, so now I want to solve both equations. Start by adding 5 on both sides of each inequality to get rid of that. So I'm left with 2x is greater than negative 2, and 2x is less than 12. Now I want to divide both sides by 2. No need to flip either inequality symbol because this is a positive number I'm dividing by. So negative 2 divided by positive 2 is negative 1, and 12 divided by 2, that shouldn't say 2, that should say 6. So 12 divided by 2 is 6. So I've got x is greater than negative 1 and x is less than 6. And now I want to go ahead and graph these on the same graph. Okay, so just like before, open circle at negative 1, open circle at 6 because I don't have any equal to bars. All right, now let's graph these. X is greater than negative 1. Well, 0 isn't either one of these 2 points, so I can use 0. 0 is greater than negative 1. Well, as I said before, 0 is bigger than every negative number, so yep, 0 is in the solution. That works. So I want to shade this one this way. And notice it's going to go all the way, and I'm going to stop it at the other circle. And the reason why is I can't go beyond either of the circles. If it's between them, it's got to stay between them. It can't go past one of the circles. Now let's test x is less than 6. Well, once again, I can use 0 as a test point. 0 is less than 6. Well, is 0 smaller than 6? Yep, it is. So 0 is in the solution of the inequality from here as well. So this one gets shaded to the right. And once again, I stop. And you can see that for this inequality, I'm just shading the area that's between the two inequalities. And that's actually a pretty easy one to remember, okay? That if when you do these, okay, one's a greater than, one's a less than, they're kind of pointing to each other, we're going to end up having shading in between. Notice I don't go to the outside of either one of them. If it's between, it's just between. So hopefully after watching this video, you have a better idea of how to solve and graph absolute value inequalities.